a rotating disk. If v equal to r omega, find the velocity and acceleration of b relative to a as the function of the time before the particle collides with the disk. So it is something. I'll give some better diagram. Now what happened? This relative angular velocity concept, we are extending it to what? One particle will be moving in circular path. The other particle, what happened? Let it move linearly somewhere in a space. Then we are going to discuss the situation. I'll giving a clear diagram. See this one. This is a particle A. This is a particle. It is moving with a velocity A. And what will the particle be? It is also moving in circular path with the same tangential velocity V only. And it's having angular velocity omega. Okay, according to the diagram is given like this. Center, take it this theta. A t equals 0 particle is here. After some time, I think I'm giving enough information to the diagram. After some time, the particle, when it is arrives here, where this particle will be? Somewhere here. Okay, got the idea, all of you? Look at the instant now. So now he's asking what is the velocity of particle A, particle B with respect to A. So now this relative velocity concept, we are extending it to the other thing. Now, can you define velocity vector of B? That's very simple. He's asking just velocity of B with respect to and acceleration of B with respect to A. No? So I'll proceed like this. So first we have to get the velocity of B with respect to A. So just it's a very, you can say the simplified approach. Can you define now velocity vector B, VB bar from the diagram? There's a unit vector, you can take it I cap, J cap. So this will be the theta, no? VB bar, how you write it? Minus V cos theta I cap plus V sin theta J cap. What is given? Omega, no? Because V equal to, I should replace, so this will be minus R omega cos theta I cap R omega sin theta J cap. And what is theta? Omega equal to theta by time, no?
Sir, you wrote you should interchange the cos theta and sin theta components in VB.
Not needed. I'm just asking.
Yes, sir.
It is written.
Sir, it is V sin theta I cap minus V sin theta I cap plus V cos theta J cap.
This one. Yeah. I'll change it. Thank you. Sin theta. This is cos theta. So this is where all theta is there. I'll replace this R omega cos omega t J cap. Velocity of particle is how much? Is just equal to Vi or R omega I cap. What is the question asked? Velocity of B with respect to. So VB bar minus VA bar. Like this, see now You come out of some relative angular velocity, nothing to do with that one. Sir, one particle moving in circular path, other is moving somewhere in a plane. Can you find out relative velocity? Just the same old definition, velocity of B with respect to VB bar minus VA bar. You know that particle, if it moves in circular path, you know that angular position theta. Then with that, you can define the velocity vector. Got the idea, no? So we can compare anything. So VB bar, so this should be equal to minus R omega sine omega t I cap minus R omega I cap. So this you can see this R omega, I'll take outside, 1 plus sine omega t I cap. Looking at the equation, don't get scared. Nothing is there in that one. If you want in terms of V, you can bring it in terms of V. Either of things. So no, sir, omega I'll replace in terms of V. You can write it. It is your convenient. Fine. So now he's asking acceleration. What to do with acceleration? Particle A, what is the acceleration of particle A? 0. What is the acceleration of B? Any acceleration is there? Centripetal acceleration. And how much should be equal to? Omega square, and it will be directed towards BO. That's all, no? So no need of any big mathematics. No need of any big mathematics. So then acceleration of A is 0. Acceleration of B is what? Acceleration of B is just equal to omega square R. Equal to only omega square. What about the magnitude? AB bar should be equal to, and how that acceleration will be directed? It will be directed like this, no? Now write the in the vector form. So this should be equal to minus of AB cos theta I cap minus AB sin theta j cap. Now what is ABA bar? This is okay, should be equal to only this AB bar, that one. So now we can compare the motion of revolving particle with some particle moving in a plane. Nothing to do. The same mathematics you are going to bring it. If it is having if it is having tangential acceleration, bring that also and compare. Are you getting the generalized method? Now we can compare motion of particle moving circular path. I can describe either with respect to center of circle or with respect to some other particle. It doesn't matter. So how to get the relative velocity is all this is the thing. How to get angular velocity of B with respect to A. Then what you should do, you should draw a line joining B and A. Things will be a little bit difficult here. So draw a line joining B and A. And from the mathematics, because in time t, what happens, this will cover a distance Vt. So how much this will be R minus Vt. This is R, this is R. Then get this length. Once you know this length here, then get the angle. Angle made with the line joining AB with these vectors AO and BO. Once if you know that angle, then resolve velocity is perpendicular to line joining A and B. Then bring the angular velocity. Getting the approach. So there's a general idea. They can ask you anything. So I just wanted to give you a generalized idea. It's not that only with respect to circle we can discuss here.
Sir, sir, here particle B is accelerating, right?
Okay, fine. Yeah.
Then in the first equation we wrote VB at time t equals 0, sir. At time t equals to t.
This is a centripetal. I don't know. This is not linear acceleration. we are
Okay, sir. Okay,
discussing,
sir.
we are describing circular motion.
Yes, sir. I got confused.
AB is centripetal acceleration. I'll write it. This is due to what? Due to change in direction of motion. Just be alert, all of you. What is AB? AB is a not like some sort of like a which will increase the speed of particle after some time when particle is here. When the particle is here, again AB will be like this.